Alright, so welcome back to our symbolic logic class. Today we are going to be talking about the different methods we have in using to test the validity and invalidity of an argument. So whenever they give you question on symbolic logic, after symbolizing, it is expected that you test the arguments whether to be valid or invalid using different method. So today we are going to be focusing on the method of truth table and abridged. Abridged is used to prove an argument to be invalid. It is also called a shortened method of proving an argument to be invalid. While truth table is used to test an argument to be valid or invalid. So today we are going to be talking about truth table first. Truth table. So let's say after symbolizing, we have a question like P implies Q, P therefore Q, and you want to test the validity of this argument. After symbolizing, you have this. You want to test the validity of this argument using truth table. The first thing that you do is that formula of the formula that we use in truth table is called 2 raised to power n. 2 raised to power n. N means the number of variables. N means number of variables. So you count how many variables do we have in this particular argument. In this one, we have just 2 variables, P and Q. So 2 raised to power n means n is number of variables. So that's 2 times 2 equals 4. That means after drawing our truth table, we are going to be having 4 different rows in the truth table. Had it been our variable is 6, sorry, had it been our variable is 3, it's going to be 2 times 2 times 2. That is 2 raised to power number of variables. Had it been the variables are 3 now, instead of 2, it's going to be 2 times 2 times 2, and it's going to give us what? 2 times 2, 4, 4 times 2 is going to give us 8. That means after drawing our truth table, we are going to be having 8 different rows. But in this situation, we have just 2 variables. So we are going to be having 2 times 2, which equals what? 4. So that means after drawing our truth table, we are going to be having 4 different rows. So after discovering that, okay, we are going to be having 4 different rows in our truth table, then let's now draw the truth table. So the first thing that you do when drawing the truth table is that you write out the variable horizontally according to how they occur in the argument. That is, we have P first, P, and we have Q. So that is how they occur. We have just 2 variables. So you write them out horizontally according to how they occur in the argument. Then that's it. You draw a line. Then write the first premise, P implies Q. You draw a line. Then the second premise, P. Then the last one, Q. So that's the first thing that you do. After discovering that, okay, we are going to be having 4 different rows, you write them out horizontally. You write down the variable horizontally. Then you write out the premises till you get to the conclusion. So now we are not going to be assigning truth value to it. Since we have just 2 variables here, the first one, you can start from the last one here. The last one, you start from the last one. So you are going to, since we know that it's going to be 4 different rows, so we have 2 different possibilities, which is true or false. So since it's going to be 4 rows, we can have it to be T, false, true, false. That is, we are starting from the last one, true, false, true, false. That's 4 different rows. That's all. Then this one is not going to be this one multiplied by 2. That is, instead of having true, false, we are going to be having true, true, false, false. Now we have already discovered the truth value of this particular variables. Then you assign it to the body of the argument. That means P is what? True, true, false, false. Q is what? True, true. Sorry, Q is true, false, true, false. P is what? True, true, false, false. Q is what? True, false, true, false. Now we've sorted out everything, all the variables, but we still have something left out. That means this particular connective. Yeah, that is where our knowledge of the truth value connectives will now come to play. Don't forget that in our last video, this is what's it called? Implication. And we said an implication is only false when the antecedent is true and the consequence is false. That's the only time that is false. So we now sort that out using that particular rule. So here we have true, true. That means this place is true. here we have true, false. This place is false because implication is only false when the antecedent is true and the consequence is false. So false true, we have true. Then false false, we have true. So we sorted that out. So now another thing that you now need to check now is we are done assigning the truth value. We just need to check whether this argument is valid or invalid. A valid argument, an argument is said to be invalid if and only if it is impossible for the premise to be true and the conclusion to be false. That's where an argument is said to be what? Invalid. So all we need to do now is to check from each row, like row 1, row 2, row 3, and row 4, whether there's anywhere we have true, true, false. If there's anywhere we have true, true, false, then that argument is what? Invalid. But if there's nowhere that we have true, true, false, then the argument is what? Valid. Now, this is the major truth value of the conclusion. This is the major truth value of the second premise. Since this is where this place is joining together, this is one that we are going to be checking for the first premise. So here we have true, true, true. This place is valid. False, true, false. This place is valid because what we are looking for is true, true, false to have invalid. Then here we have true, false, true, valid. True, false, false, valid. Since there's no place that we have true, true, false in each row, then this argument is what? Valid. Now let's have a situation. Let's now imagine a situation whereby we have this particular place, this last place to be here. We have it to be true. Then this one we also have true, false. Let's say we have true, true, false instead of true, false, false. Let's say we have true, true, false in this place. Then we say this argument is what? Invalid. After writing invalid, you will now count the row 1, row 2, row 3, row 4. That means the invalidity actually occurs in what? Row 4. So you said invalid row 4. Let's assume a situation whereby, just like the way this row 4 is having T, T, false, let's say the row 1 is also having T, T, F. So we are going to know that, okay, the row 1 is also invalid. So we say invalid row 1 and 4. Invalid row 1 and 4. So that is how to test the validity of an argument using truth table. Let me give us another example so we can see clearer on how to, test an argument to be valid or invalid using truth table. Let's say the first place now we have R implies E. Then the next one we have negation R implies S. Then our conclusion is now E or S. So now we already know that our first thing to discover is that our formula 2 raised to power n. N is the number of variable. How many variable do we have here? We have R, E, and S. R, E, and S. That means we have what? 3 variables. That shows that after drawing our truth table, we are going to be having 6 different lines because 8 different lines. 2 times 2 times 2. 2 times 2, 4. 4 times 2 equals 8. So we are going to be having 8 different rows after drawing our what? Truth table. Don't forget that the first thing that you do is to write out the variable, how they occur in that argument horizontally. So the first one is R, the second one is E, and the last one is S. I draw a line. I got that's the first premise. R implies E. I draw a line. I write out the second premise, negation R implies S. I draw a line. Then I write out the conclusion, which is E or S. So now let's now assign the truth value. Don't forget that you can start with the last one. The last one is going to be just one. True, false, till you get to that A true. Don't forget. True, false, true, false, true, false, true, false. 1, 2, 3, 4, 5, 6, 7, 8. Then since we already have this one to be 1, the next one is going to be times 2. That's 2, 2. T, T, false, false, T, T, false, false. Then since this one is already 2, 2, the next one is going to be times 2, which is 4, 4. So T, 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 false, 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 false. So is it clear? We have already discovered the truth value of each particular variable. So let's now assign it to the body of the argument. R is T, 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 T. False, 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 false. E is T, T, false, false. T, T, false, false. Okay, now since R is already T, 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 false, 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 negation R is going to be what? False, 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 false. T, 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 T. The rule guiding negation is that, let's say we have P, negation, we have P, and we also have negation P. If P is true, negation P will be false. If P is false, negation P will be what? True. So that means anywhere we have R to be T, 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 negation R will be false, 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 false in that place. So that's what I did there. So T, 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 that's for R. Negation R will be false, 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 false. Then false, 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 T, 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 T. So that's what I did there. So now the next one is S. S is what? T, F, T, F, T, F, T, F. Then E is what? T, T, F, F, T, T, F, F. Then S is what? T, F, T, F, T, F, T, F. Now we've already sorted out the unproblematic proposition there. So let's now come to the connective, that is where we have two different propositions joining together. So this is implication sign or conditional. Conditional is only false when the antecedent is true and the consequence is false. So T give us T, T give us T, TF give us F, TF give us F, FT give us T, FT give us T, FF give us T, FF give us T. This place is also conditional. Conditional is only false when the first one, that is the antecedent, is true and the consequence is false. So FT give us T, FF give us T, FT give us T, FF give us T, TT give us T, TF give us F, TT give us T, TF give us F. So now this one is disjunction, and disjunction is only false when the both disjuncts are false. A disjunction is only false when the both disjuncts are false. So true give us true, TF give us T, FT give us T, FF give us F. It is only false when the two of them are what? False. TT give us T, TF give us T, FT give us T, FF give us F. So now we are done assigning all the truth value. Since this is the major connective in this particular place, that means this is what we are going to be checking when we want to check the truth value of each premise, whether it is valid or invalid. Then this particular one, this is what we are going to be checking, because this is where the two of them are coming together. Then for the conclusion, this is where we are going to be checking. So let's check for rule 1. True, 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 valid. True, 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 valid. False, true, true, valid. False, true, false, valid. True, 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 valid. True, false, true, valid. True, 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 valid. True, false, false, valid. So this is also a valid argument. But in a situation whereby after doing it, let's assume we have this place, we have it to be true, true, false, or we have this place to be also to be true, true, false. Let's say these last two rows now, after checking it, we have true, true, false, and we also have true, true, false. So it's going to be what? Invalid. Row 7 and 8. So, but because there's nothing like true, true, false in the two of them, that is why we just said it is what? Valid. So let me return it. So the only thing that makes an argument to be invalid when we are checking our truth table is true, true, false. Every other option is what? Valid. False, 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 valid. False, true, false, valid. False, true, true, valid. True, 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 valid. True, true, false, invalid. So let's now go to abridged. Like I said earlier, abridged is a shorter method and it is used to prove an argument to be invalid. So let's assume that after symbolizing, we have something like A implies G, M implies G, therefore A implies M. Now this is our abridged. So let me just write it in the middle since it's not going to take a lot of space like that. So let's assume after symbolizing, this is what we have, and we now want to test this whether it is we want to prove it invalid using abridged method. So now we already know that an argument is said to be invalid only if we have all the premise to be true and the conclusion to be false. Only when we have true, true, false, that is when an argument is invalid. Since we already have that knowledge, all we just have to do is to write out a T false. Now the argument is already what? Invalid, because it has already given us true, true, false. So what we're now going to be doing is that we are going to be assigning truth values to this variable in such a way that we are going to be having this true, true, false. The conclusion is what we are going to be sorting out first when you are doing abridged, because it's the conclusion that is going to lead you to the truth value for the variables in the premises. So the conclusion is having implication sign. That means for implication to be false, an implication is only false when the antecedent is true and the consequence is false. So for this implication to be false, we are going to be having the antecedent, which is A, true, and the consequence, which is M, false. So we give A true and we give M false. So the conclusion is already what? False. Since we already know the value of A, I'll just assign it to this place that, okay, A is true. I don't know the value of G, but I know that this is also implication. I don't know what to give G, but if I want this place to be true, because I want the first premise to come out as true, but I don't know what to give G, but from this conclusion, I already know the value of A, which is true. If I give G, if I give it false, it's going to come out as false, so I cannot give it false because I want it to be true in such a way that I'm going to be having all my premise true, true, and conclusion to be what? False. So since A is already true, if I give G true, this space is going to come out as true, but if I give G false, this space is going to come out as false. So I'll give G true. So it's going to be true implies true, true. You know, in implication, it is only false when the antecedent is true and the consequence is false. So since the antecedent is already true, if I make the consequence false, that means the implication itself is going to come out as false, and that's not what I want to achieve. Abridged is used to make an argument invalid. So I gave the G true. So I already know the value of M. M is false from here. I already know the value of G from here. G is also what? True. So if you look at it now, you see that we already have the argument to be invalid because we have it to be true, true, false. In implication, it is only false when the antecedent is true and the consequence is false. So true implies true, true. False implies true. Is it still implication? True. True implies false, false. So we have already proved this argument to be invalid using abridged. But for the purpose of exam, you might decide to draw the table. Abridged also has table, just like true table. We also have abridged table. So the first thing that you do, we already know, is that you are going to be writing out the variable according to how they occur in the argument first. A, G, M. That is how they occur. Then you draw the line. The first premise, A implies G. You draw another line. M implies G. You draw the next line. Then the conclusion, A implies M. We already know that abridged wants it to be true, true, false. So it's very, very simple. The first thing you do is that you write this under this place, the first premise, you write it as true under where they are joining together. This place, where they are joining together, you write it as true. Then where they are joining together, you write it as what? False. So now you can now look at the one that we did before. What do we give A? We said A is true. What do we give G? G is also true. What do we give M? M is false. What do we give G? True. What do we give A? True. What do we give M? False. So if you should look at it very well, it's still the same thing. True implies false, give us false. False implies true, give us true. True implies true, give us true. Then you write the variable under this place too. A is what? True. G is what? True. And M is what? False. So that is how to prove an argument invalid using the abridged method. So let me give us a more complex example, then we are still going to solve it out here. So we have the first line, open brackets, L and H, close brackets or close parenthesis, implies open parenthesis N and B, close parenthesis. Then open square brackets, open parenthesis, H and negation L, close the parenthesis, implies E, close the square bracket, and open parenthesis E implies B, close the parenthesis. Then the third line, L implies H, then the conclusion B. Like I said, the first thing that you're going to do is the conclusion, or the first thing you're going to do is to write it as true, because that's what we are looking for. True, true, then false. All the premise to be true and the conclusion to be what? To be false. Like I said, in Abridged, you start with the conclusion. So we already know it, the conclusion is already obvious that it's going to be false. So B is already what? False. So now it's not this knowledge of B that is false that you are going to use to resolve the premise. So since B is already false, anywhere there is B, give it false. B here is already false. Also B here is already false. So that's the first thing to do. Now, there's no one straight way of resolving Abridged. You can start anywhere, but before assigning truth value to anything, you have to think critically about it first. Now, I already know that B is false. If I should look at my major connective in this case is conjunction, and in conjunction, a conjunction is only true when both conjuncts are true. And don't forget, I want this place to come out as true. So that means anything that I'm doing in this conjunction, this place must be true, and this place must also be true. So, but B is already false. I don't know what to give E. So let me say if I give E to be true, this place is going to be true implies false. Then this place, this whole place is going to come out as what? False. But that is not what I want to achieve, because this is a conjunction. And in conjunction, the two of them has to be true. So I will say I'm giving E false. I'm giving E false, so that when I give it E false, I'm going to be having false implies false. It's giving me true. So this place I already stand. So I already know the true value of E. What I need to do is to assign it to this place too. E is already false. E is already false. But I don't know what to give everything that is in this place. But the same conditions still apply. I have to assign truth value in such a way that this whole place is going to come out as false, so that it's going to be false implies false is going to give me true. Because if I make this place to come out as true, I'm going to be having true implies false, which is going to give me false. And this is a conjunction. And in conjunction, the two of them, this one has to be true. Everything here has to be true when it comes out. And everything also here has to be true. So I've already said E is false. So that means this whole place, I have to find my way. I have to find my way of making this whole place to be false as well. So let's look at it. So let me say I give I'm looking at it. So let me say I'm giving this H false, and I'm giving negation L true, I'm giving negation L true. This place is already false and true, so it's coming out as false. Then false implies false is giving me true. That means this whole line is already sorted out. So H, which is I gave H false, I give this one true. So false and true is coming out as false. The false implies the false that is here is coming out as true. That means this whole square bracket is true. And this space, false implies false, this one is already coming out as true. So truth and true is giving me true. Since I've already sorted out the truth value of this particular place, so this place is easier for me. So I will just say H is already false. H is already false. Don't forget that negation L is true. That means L will be what? False. So this place is already sorted out. False implies false, give me true. So I already know the value of L. Value of L is already false. Then the value of H is also false. Then B is already what's it called? False. So this place false and false is coming out as false. It's coming out as false, but this is implication sign. That means this place, this whole place can be true and it can be false. But since I already have B to be false, this N does not matter. If I give it true, it will work. If I give it false, it will work because N is only occurring once. So anything I give it in this place will not affect any other place. So this one is already false and false. Is already coming out as false. Then implies, if I say N is true, it's still true and false, it's still going to give me false. And if I say N is false, it's still false and false, it's still going to give me false. So let me just say N is true. So it's still false implies false and it's giving me true. So that is all. So with our knowledge of the first one that I did on how to assign the table or how to draw a table and assign the truth value, so you can actually take that as your assignment. Challenge yourself to see whether from this my abridged method you can actually draw the table, putting out the different truth value to the different variable. So for the purpose of recap, what we have done so far is that we have discussed truth table, and I said in truth table you can use truth table to test an argument to be valid or invalid. The first thing you do is that you get out the formula, which is 2 raised to power n. N means number of variable. Number of variable in the sense that we have 2. If you have 4 variable, it's 2 times 2 times 2 times 2, that's 16. If you have 2 variable, that's 2 times 2, that's 4. If you have 3 variable, that's 2 times 2 times 2, that's 8. So the number of variable that you have is going to determine the number of row that you're going to be having after drawing the truth table. Then you write out the variable according to how they occur horizontally. After doing that, you assign the truth value starting from the last one, 1T, 1F, then the next one, 2T, 2F, the following one, 4T, 4F. That's in the situation whereby we have about 3 variables. So after assigning the truth value for the whole variables, then you go to the body of the argument and also assign the truth value for everything. If there's any way that you have the if there's any way that you have the compound proposition coming together using different connective symbols, you are going to use your knowledge of the truth value of those connective symbols to bring out the major truth value of that particular row or of that particular premise or in that particular premise or in conclusion. Then after doing that, you check out to see whether there's any way that we have true, false. If there's any way that we have true, false, the argument is invalid, then you are going to state the row where the invalidity occurs. But if there's no place that we have true, false, then the whole argument is what is valid. So now moving down to Abridged, like I said, in Abridged we use Abridged to test an argument to be invalid. So after writing out or after symbolizing the argument, the first thing you do is that you write true, false. True to all the whole premise. If it's one premise, true, then the conclusion false. If it's 2 premise, true, the conclusion false. If it's 3 premise, true, then the conclusion false. So you assign truth value to the body of the argument in such a way that you are going to be deriving the first premise, second premise, third premise to be true, then the conclusion to be false. So then after doing that, you draw out the table. You draw out the table, writing out the variables according to how they occurs in the argument horizontally. Then after doing that, you write out the premise till you get to the conclusion. So you write out the true, false, then you assign the truth value that you have already assigned to the body of the argument or to the variables here, then you assign it to the table as well. So in our next video, we are going to be talking about how to make use of rule of inference, rule of replacement, and also the rule of inconsistency. So thank you for watching. Stick around as we go to the next video.